Hello again, guys. Those of you who saw my previous video on this Gecko Drive G540 heard me mention that I had gotten this with the intention of working on making a CNC. Well, today let's talk about the rest of the project. In this box here I have a bunch of the stuff that, I just kind of piled it together for the purposes of this video. But anyways, there's a bunch of the stuff that I'm going to be using as part of this project that I've kind of collected over the months, years. Like I said, it's been a while in the making and it hasn't really gone very much of anywhere. But hopefully me trying to make these videos will kind of get me motivated to try to finish up the thing. So as you can see, there's quite a bit of stuff in here. Connectors and wires and switches and power supplies, all kinds of crap. I'll explain everything that I'm going to be using, or that I'm planning on using for this project. This is that box that I was talking about that I'm going to be putting the Gecko Drive in. And up here in the front I've covered it with tape. You can tell that it's been here a while because it's all kind of like damaged on the edges and like frayed and stuff. But anyways, like this right here is going to be the cutout for the motor driver. Then I'm going to have a cutout here for like this little screw terminal strip where I'm going to have the inputs for like the mains, and then to be able to like drive the like router, turn on and off and stuff. Here in the corner I'm going to have a 15 amp breaker, so that's going to sit like right there, so in case like anything, you know, that's being powered by this whole thing decides to short or whatever, this breaker would just shut off and turn everything off that's in this box, because this is going to be like the main like control box and power supplies. And then I'm going to have two cutouts here for these connectors, these multi-way connectors. Each one has a total of 9. So like for example, there's going to be one here for all the limit switches and like home switches, and then I'm going to have like a ground, as you can see right there. And then for the EStop, and then I have like the 3 other ones that are for the VFD control, or that's the variable frequency drive, in case in the future I want to, you know, get a VFD with the motor and everything and use that as my spindle. And I'm trying to kind of make things as organized as I can. Like this here I've zip tied and I've cut all the wires to length so I don't have like a bunch of extra. And how that's going to work right there is that I've got the Gecko Drive here, and these are going to go to the bottom terminals here, and then that way, you know, it keeps everything looking kind of neat like that. Like say this is going to be mounted in the front here, I'm going to have the connector out in the front like that, and then all I got to do is just insert each wire into these here once I strip them back. And that'll keep things kind of organized. I'm trying to, you know, make this look as nice as possible. I don't want it to be like a big jumbled mess of cables and everything. And then, so yeah, so there's the like the mains strip, and then there's going to be this other strip on the inside here where I'm going to have like all the connections for power. So, you know, we got the live, we got the neutral, and then I'm going to have like a ground and like a 5-volt output, a 12-volt output, and then I'm thinking about one from straight from the power supply that's going to be powering the Gecko Drive, but I'm not sure yet on that one. So that's that. I've still got to finish crimping on a few other things here. As you can see, like we're going to have the mains come in from here. That's going to go to that breaker, and then from the breaker it's going to go out to the strip, and then from the strip here we're going to hook up this is the main power transformer that's going to be powering the Gecko Drive. So I'm going to attach those here, and then also I'm going to have this other board here. That's originally this was supposed to be to drive the router, and what I had done here is I have a relay that allows power from the mains to be cut off from this triac here, because what I was thinking of doing was possibly using some pulse width modulation to be able to control the speed of the router. But what I didn't take into consideration is that you can't just turn on a triac at any, you know, particular random point in time and have it function the way a DC motor, like a MOSFET on a DC motor controller would work, because of the fact that, you know, you got like a sine wave of like AC is a, you know, a sine wave. And so if you turn it on like at some random point, the motor's going to be like jumpy and all over the place, and which is exactly what was happening. So unless I had some way to detect, like, you know, like the zero crossing on the AC signal, and then be able to like trigger, you know, like a point after that, it's really not gonna work very well. So I don't know, I might end up taking this out and instead just making it with like one relay, and or maybe like making a 2 relay board, because what I have here is I actually have 2 inputs and they're both driven by pulling them low, which is what the 2 outputs on the Gecko drive do. They pull low. So I could have 2 relays, one that controls the router on and off, and then another one for like some other function, maybe like a vacuum or something for a dust collector. So yeah, I'm not sure yet, but this is what I was going to use. I can still use it as just like an on and off for the router as is, and it works fine. And there's like the screw terminals here, so I would have one coming in from the live and then one going out to the router output on the screw terminals here. So that's what that board is. And as I mentioned, this transformer I got from a UPS, and I rewound it to give me the voltage output I wanted to use here. Although I think I might end up taking it apart again and rewinding it for something closer to 48 volts, because as is right now I'm getting about 41 volts DC output, like once it's rectified. And it works a lot better than what I was originally intending on using, which was one of these power supplies. And these, if you can tell right there, it's a 24 volt, it's kind of blurry, but it's a 24 volt power supply at 6.5 amps. It's a switching power supply. Unfortunately, for the motors that I'm using, it didn't seem to be enough, and I kind of had a few like performance issues with that. So that's why I decided to go with just this linear setup for now, because this actually worked out pretty well. These transformers, or this transformer that I got from this UPS, just had a weld going across here on both sides. So this is like the whole I section, and this is the whole E section of like the core. So I was able to easily just grind those off, and then I could pull this off. I pulled out the coils in here, and then I just figured out, you know, the ratios of voltage in to voltage out, like the windings. Did that, so I got close to about 40 volts DC output, which I said works pretty well. So I don't know, I might just leave it like that. It works pretty well. This is the rectifier board with the caps. So basically all it's doing is it's just taking the AC input from the transformer, going through a bridge rectifier here to these caps that, you know, just hold the charge. And then I got a little fuse here just for protection. And then we have ground out. We got the full unregulated voltage out from the rectifier. And then I have another separate little LM 350 regulator here, and I can set it to 24 or 12 volts output here, just in case like I wanted to drive anything else, like maybe some relays or something. This is one of the ones that's probably going to get like routed out so that I can, you know, have some external power for other things. So it's a pretty simple board, and if needed to, you know, I kind of made these sort of like modular so that if I ever want to change anything, it's not a big deal or like a big hassle to do so. Got a heat sink on the rectifier because it does get pretty warm in operation, and so that kind of helps it out a bit. And speaking about heat, I'm planning on putting this little fan kind of here in the back, so I'm going to be cutting out a hole, and then this fan will sit there, and I'm going to cut out like a piece of plexi that's going to sit over the top of this, and then I'm going to have like holes, you know, like drilled out over the top in like certain spaces or certain areas, so that way, like, you know, like as the air kind of like flows in, it flows over like heat sinks, and you know, kind of just cools everything as it goes, makes its way out. The transformer is going to be, I want to have like sitting here in the corner, so, you know, I'm not too worried about this one getting too hot, because it really doesn't get that hot in operation, or at least from like just testing that I've done, it doesn't tend to get too hot. So a lot of the heat's going to be generated by the motor controller, and so I'm going to have a lot of air coming in through there, you know, kind of flowing across and out through the back. And then this power supply here is from an old like external CD-ROM drive. This puts out 12 volts at about 2 amps, and then it can do 5 volts at 3.5 amp. This, as I said, is probably just going, the 5 volts are probably going to be used to, you know, drive a few other external devices or whatever. I think I might even use it on the inside of this to have like an automatic fan regulator, so that the fan's not running on high all the time. It's just if it, you know, starts getting kind of warm in here, then it, you know, speeds up or whatever. And I'll probably use an Arduino to do that. And then the 12 volt of this I have going out to a jack, and this is going to be used to power the LCD monitor that I'm going to use. I'm going to be using a little 15-inch LCD monitor that I actually converted into a touchscreen, because, you know, that way I can just kind of like tap around. I don't have to be worrying about like having a separate mouse or anything. So that's going to power that. The monitor uses 12 volts obviously, and 2 amps should be plenty to drive it, because it really, I've used it with the 2 amp power supply. It works pretty well, so it should be fine. And then here's the mains input. I'm going to be, you know, connecting this to that screw terminal strip that's going to be down there on the bottom. And I'll show you guys how I'm planning on laying this out right here in a second. Like I said, fan in the back. And so here's some of the connectors I'm going to use. These are the ones I'm planning on using for the motors. So one of the ends, I think it's going to be probably the male end. I'm going to crimp to the motor wires here. Like, this connector's not going to stay here, obviously. I'm going to take that off. So the end with the male pins, you know, going to be crimped to that. And then I'm going to have this other cable that I have here. It's 4 conductor cable. I'm going to crimp those. I only need 4 spaces. These are 6, but I just happen to have them around, so that's why I'm going to use them. I was thinking about buying some 4 position connectors, but I was like, well, why am I going to waste the money? I already have these, you know. So these are going to go here, and then the motor's going to have the male on like that, you know, and then I can just connect them, and if for whatever reason I need to disconnect them, I can. So that'll make things a lot easier. And as I said, I have several sets of these, so I'm set with those. These are the ones that are going to match up with these connectors that are going to be on the outside. I actually have 2 of these. The one, as I mentioned, is going to be the one that has all the, like, the limit switches, home switches, EStop, and then the VFD outputs. And then the other one, which I don't know what I did with, I just had it somewhere on here. Oh, I'm sitting at such a bad angle here that I didn't even see it. It's in here. So this is going to be the power outputs for powering external devices. So right now I only have 4 positions to use, but I have another 5 that I can use for other things later on if I need to add anything. So that's that. That's going to go also to that terminal strip. As I said, I'm trying to keep everything as organized as possible and as neat and as nice looking as I can. So I've crimped all these little ends on the wires here to make them look pretty nice. So these 2 will be sitting right here in, well, I don't know which order exactly I want to do yet, but they're going to be sitting out in these spots. And they have these kind of like locking tabs in the front, which they can only be inserted in one direction. They have these little kind of notches, and then like right here they have these little pieces that once you put them in like this, they lock into place. So these, there's not going to be any easy way to accidentally yank them out. Like, you know, if kind of happen to be walking by, something gets caught, whatever, can't yank them out. You got to squeeze these in, and then you can pull them out. So that's going to be pretty cool. And as we saw on the connector here, or on the connectors on the motor controller, everything's kind of like screwed in, so, you know, you can't accidentally just pull anything out while it's in operation. And that's kind of why I wanted to use these, because they lock in, can't pull them out. So that's those. Up here in the front, I'm going to have like a little hole. That's where that 12 volt connection for the LCD is going to go. So this is kind of a crude look at how I want to lay out everything inside. I still have to get standoffs and screws for all the boards and everything, and the transformer to be able to, you know, kind of like make it permanently in place. But that's kind of what I'm expecting things to look like. You know, this terminal is going to be right there. We got the connectors on the bottom. That terminal strip here is not going to be that far in. It's going to be more like over here somewhere. And then, you know, power supplies, all that stuff. So that's what I'm hoping things will look like once I get everything in place and all the front pieces cut out and all that. So maybe next video, once I do all that work, you know, you'll actually be able to see what I'm picturing for this whole setup. So as far as some of the outside components are concerned, you know, like outside of the control box, these are going to be the limit switches and home switches that I'm going to be using for the machine. They're normally closed, which is perfect because these need to be all arranged in like series. So as the machine's moving in one direction, you know, like say going towards home, and it hits that switch, you know, it knows that that's where it needs to stop, and then, you know, for its limit, it's going to be like on the opposite end. And I have like 10 of these, I think, so they're perfect because I think I only need like 6. So I can have those. I was originally planning on using a bunch of micro switches, and I have quite a few that I've taken from things like, you know, other machines and like microwaves and stuff like that. Except that I don't have like a bunch of consistent looking ones, and they're all like, some have like different tabs and things, and I didn't want to like, you know, stick a bunch of like funky looking switches all over the place, and I wanted to have something that, you know, that were pretty much going to be all the same. So I had these, so that's what I'm using. So these are the motors that I'm planning on using here, these 3 big NEMA 34 frame size steppers. When I first kind of got into the idea of making my own CNC, I had this little NEMA 23 motor kind of laying around that I thought, well, if I can get like 2 more of these, you know, I can make myself like a little CNC. And I mean, this would have been okay for something small, and it would have worked fine, but I didn't, like I said, I didn't have 2 more of these, so I would have had to figure out where to get 2 more or something similar or whatever. And then an uncle that gave me this one of these big stepper motors, and along with this other motor driver for it, which I might actually do a video on later because it's actually interesting as well on its own. But he gave me this big stepper motor, and I thought, wow, shoot, you know, well, that'd be cool. It has a lot of torque, and I thought that, you know, I could use this for part of it, you know, and then maybe just get like a couple other motors. So it would have been like this kind of like this whole Frankenstein mess. But then I mentioned to an uncle about how I, you know, was thinking about using this motor for a CNC machine, and he says, oh, well, I got a couple more. So perfect, I got 3 now. The only thing that I kind of screwed up on was that before I really knew too much about these stepper motors, I kind of, as I mentioned in the other video, you know, got to look inside of things, got to figure out how they work. So this one I had previously taken apart, you know, so I knew what was inside and, like, you know, how the clothes looked and everything, and I thought, well, cool, let's see how the ones inside this motor look. And some of you that know already kind of know where I'm going with this. But I took it apart, and what happens is when you take these stepper motors apart, you're supposed to use what's called a keeper that goes over the big magnet in the middle, which is actually the one that drives the shaft, and that kind of helps keep the magnetism in the magnets. Well, I didn't know that, and I took this apart, pulled the rotor out, and, you know, just kind of looked inside to see how the whole thing was built. No, put it back together, didn't really think much of it. Well, what I realized is that when I did that, because it loses some magnetism, the torque on this kind of dropped. And it's really apparent if you notice here, like if I try to turn this one, it's a little more difficult to turn. And trust me, I'm trying here. I mean, I'm not trying like super hard. I can easily like turn this, but I'm like, you know, putting a little bit of force here. And this one's a bit harder to turn than the one that I took apart is. As you can see, I'm really not putting that much effort into turning this one. I mean, it still holds fairly okay, but it's nowhere near what it used to be, like it is with this one here and this one here. So that was my mistake. So I'm planning on using this one as part of the Z axis, just to lift and, you know, drop the router, and then I'm going to use these for X and Y. So after my uncle gave me the motors, and he knew, you know, that I was going to be building this machine and stuff, he also got me these pulleys and these belts that he also had just laying around. It was from like some old equipment, I guess, that got dismantled, and he just had them sitting around. So I've got the belts, I've got the pulleys, and these are a 3-to-1 reduction. So the pulley has the pulley on the motor has 12 teeth, and then this pulley over here has 36. So this, you know, will help reduce it quite a bit, and maybe give me a little bit more, you know, torque. And because they are tooth, they, you know, they hold their position pretty well. So I don't have like they don't have like any slack or anything. So I think that should work pretty well. I was originally just planning on doing like direct drive until he told me that he had these too and that I could have them. So awesome. For my EStop, I was originally going to use this little micro switch with this joystick button, which I got from a local electronics store. And I mean, it would have worked. You know, once the software detects that this would have been hit, it would have just shut off. But it's the problem is that it's fairly easy to push. I mean, it doesn't take much force to get it to activate, which wasn't going to be a good thing. So what I was planning on doing was kind of like making a sort of a cup that set out, you know, like a little bit above, so that way you couldn't just like, you know, like be walking by and accidentally brush it and push the button, but you know, you had to purposefully like put, you know, your finger inside the cup to be able to push the thing. Then I came across these on eBay, which admittedly are not the, you know, the greatest thing ever. They're kind of cheap, but they're not horrible. And I got both of these for like $5 shipped, I think. And I'll probably, you know, I'll link the seller below that I got them from. And they have 2 switches each. The set comes with both of these for like $5. So they both have 2 switches, and one's normally closed and the other one's normally open. So, you know, once you hit the EStop, the one that's normally open closes, and the one that's normally closed opens up. So that's you know, that's how they operate. And as I said, they're not no awesome quality or anything, but they will work. And for something like this, you know, it's just kind of like a little hobbyist project, a DIY thing. I mean, they're more than enough. I'm not going to complain about these. So for a router, I had this router that I bought years ago, and I only bought it because I needed something to like make some cuts or whatever. I normally don't use a router for very many things, but anyway, they got this cheap. I think it was like 30 or 40 bucks or something, and it's a Buffalo Tools brand router. I mean, who knows who actually makes it, but it's like one of those cheap things you can get from like the car store. Actually, a car store had this. So anyways, it's yeah, it's not the greatest thing. It's not terrible either. I mean, I'm sure there's probably like a lot worse. So for the meantime, I'll probably stick with using this one, you know, just to get everything started, and then maybe later on I'll upgrade to something better. As I said, I wanted it to, you know, be that I can control the speed. So I don't know, maybe I'll end up making sort of a motor controller for this too, once I can figure out how to do that. Although I might, for the, you know, initially maybe just have on and off with that the relay and that triac board that I showed you guys earlier. So yeah, that's it. Maybe if I come across a pretty good deal on, you know, like a better router, like a Bosch or something, jump on that. But I guess this will have to do it for now. So that's my intro to this project. I'll be recording more as I go along, as I, you know, build more and more of it. As I mentioned, pretty much all the electronic components I already have, and, you know, some of the mechanical stuff. It's just a matter of building like the rest of the machine, the gantry, all that kind of stuff, the linear rails and all that. So as I do so, I'll, you know, recording more. So thanks for watching, guys, and I'll see you guys next time.